Hello, good evening, everyone. Welcome to Science on Tap. Thank you so much for coming. What a great crowd we've got. Our best post-COVID crowd yet. So thank you all for coming. My name is Susan Knight. I work up at Trout Lake Station. And Science on Tap is an example of the Wisconsin idea, the idea that the borders of the university are the borders of the state. Our partners in Science on Tap are UW Trout Lake Station, UW Kemp Natural Resources Station, the Minocqua Public Library, the Wisconsin Alumni Association, and our hosts here, Oak Fire, as well as WXPR, our great local public radio station. And Science on Tap is supported by a grant from the Brittingham Fund to the University of Wisconsin-Madison. And don't forget, there are always 3 ways you can watch. You can come right here, as you all are right now, or you can watch from home. You can watch live, or you can watch them later, because they're all on YouTube and recorded, so you can watch them anytime. Our next speaker will be Sean Rossler of the Wisconsin DNR, and he's going to be talking about otters. And so I don't think we've ever had anybody talk about otters. I heard him speak at the Wisconsin Lake Convention a couple years ago, and he did a fabulous job, so I hope you all can make it. But tonight we have Jim Head. Jim's interest in astronomy started when Sputnik flew overhead. A few of us probably remember when that happened, 1957. Jim was only 5 years old. His educational and work career veered more toward electronics and computers. He started his own microcomputer company in Sacramento, and then started several other companies and helped advance science programs in elementary schools. He got back into astronomy in 2004 when the amateur industry had improved to the point of including electronics to control the telescopes. So both of his loves were combined together, the electronics and the astronomy. He started the Northwoods Explorers to bring astronomy to our Northwoods community with the hope that it would help the public and students learn more about our amazing universe. Jim is a NASA JPL, Jet Propulsion Lab, Solar System Ambassador, and as part of that, he provides valuable and insightful information on many of the unmanned missions that have launched to explore the solar system. He believes it is important for our youth to realize that there are many opportunities to have a career in space science. So here's your trivia question. After high school, Jim was anxious to get on with his life, and he gave himself a week to find a job. If he didn't find an interesting job, what was he planning to do? A, sign up for the Air Force. B, drive the Pan American Highway from Alaska to Panama. C, train to swim across the English Channel. Or D, move to New Zealand where he had an aunt and uncle. All right. D? B. Any other guesses? It was A. He was going to join the Air Force. All right, Jim Head.
Thank you, everyone. Well, thank you very much for everybody coming. Everybody's online. I'd recommend going outside right now and go look at Venus and Jupiter and the western sky. It's just absolutely beautiful. There are going to be many other opportunities, and I'll get into that in a bit. But thank you for coming and inviting me to the University of Wisconsin. I greatly appreciate it. I just want to mention a few notes here. I have my cheat sheet here. So it's an exciting time to get involved in our future. With the commercialization of space, the incredible discoveries in space, and the improvements in backyard telescopes that make it easier to observe the heavens. But why astronomy? Well, astronomy widens our perspectives, brings people together, provides hope for a better future, helps us discover what an amazing universe we live in. In fact, the more you study the universe, the more you realize what an amazing planet we live on here. And most astronomers, they don't know anything about planet Earth. They've been looking at the heavens, and the more they look at them, see all the exoplanets and how terrible they are, they look outside and they go, oh my gosh. Even kids, over the 20 years I've been doing star parties and stuff, I used to ask kids after doing an activity or something, what's your favorite planet? And most of them would say Saturn or Jupiter. But 5 years ago, that changed. Now they all say Earth. So most nations are challenged with finding enough engineers and scientists. So learning about a larger neighborhood high in the sky helps them keep them curious and interested in science. The process of understanding our universe supports most all the various fields in science, as well as media, communications, and nearly every other aspect of living a life here. So NASA, if you go look at their jobs they have, it's incredible. I mean, they want artists, they want media people, they want designers, they want people who can communicate, as well as scientists and engineers. And so I read a story this morning about, this is National Women's Month at NASA, and this one lady, she decided to be a makeup artist in LA and went to Hollywood, and then she became a model, and then she ended up wanting to take some more classes in New York. And then she found a mentor and she started getting involved in physics and math. And now she works at JPL designing missions to space. And so, I mean, it's open to anybody, and the space tourism is just incredible, and I'll get to that in a bit. So the process, the universe is so large, this is the most fascinating thing to me. The universe is so large that even at the speed of light, it can take hundreds, thousands, millions, or billions of years for the light to reach us. So with that, we have an unfolding history. We can go out there and look at different places and see the entire universe unfolding before our eyes. We can see how it was a billion years ago. We can see how it was a million years ago. We can see how it was 1,000 years ago. So we can have examples of all the different types of stellar evolution from every star types, from every type of galaxy and stuff, and the more we look, the more we find out. Now, the hard part about it, though, is that because of dark energy and dark matter, we never can see the edge of our universe. It just goes on and on and on and on and on. If anybody's wondering, is there an edge? We'll never find out. Our observable universe is 13 billion light years out. The actual universe, because the universe has been expanding, things are going faster than the speed of light from our perspective, even though it's against the physical laws to go faster than the speed of light. It's because they're not going faster than the speed of light, but from our perspective, they are. If you have any questions about that, you can ask me afterwards. So the history, I've been involved in astronomy and public outreach for the last 20 years. I came to the Northwoods 5 years ago to live in a more peaceful location on a lot that my grandfather acquired in the 1940s. My parents are from Wisconsin. I travel here every summer, and now I fortunately live here. I love it. I built a new home with an observatory on Mercer Lake, just west of here, and I put an observatory on top, of course. Has a 30-foot pier. It's over 28,000 pounds of cement to be able to make sure that it's steady and it's isolated from the house so no vibrations in the house will affect it. I don't have it operating completely yet because of COVID. It took me 2 years to get all the equipment. It just arrived 2 months ago, so hopefully I'll work on it this summer. My eventual goal is to get students out there and mentor them, as well as do some serious imaging myself. So I started having no astronomy up here that I could find. I started an astronomy club, having been running a couple of them in the San Francisco Bay Area before I got here. And now we are a nonprofit public corporation with about 30 members, and we have hundreds of people on our event notification list. And we have a sign-up sheet over there that you can sign up, or you can go to our website and just send us an email, and we'll just let you know. Our email list is very secure. We don't share it with anybody, and then we'll let you know when our events are. So that's all pretty exciting. Some of our programs is that we involve celestial study. We have talks from scientists. We have a couple of them coming up from University of Madison and Stevens Point. We have educational programs. We go out to libraries and different schools. We're involved in daytime solar astronomy too, where we have hydrogen alpha solar telescopes that looks at the chromosphere. The sunlight coming from our sun is the photosphere. There's a layer above that that's the excited hydrogen that's cooling down. And as it cools down, it mirrors the entire structure of the sun. So when you see all those fantastic images from NASA on TV of the big prominences on the limb of the sun, we can see those in our telescopes. And you don't see it, there's like a fast motion that they're doing, a time motion that they're speeding up in those images. So ours, you can't see that motion right away, but if you carefully study it over a period of 5-10 minutes, you can see the whole sun kind of bubbling and stuff. It's really exciting. So even in the daytime, it can be fun. We're involved in citizen science. There's a lot of activities people can do at any age to help support other sciences with data collection, confirming their findings and whatnot. And then we have help with telescopes, and we have, if you become a member of our club, you can borrow one of our telescopes and learn that way. We do not recommend you go out and buy a telescope. I think you should start with binoculars if you really want to get more power to your eyes. You realize our eyes are only like, 5 millimeters at best. And so if you get a 50 millimeter binoculars, you've just multiplied it by 10. So the more light gathering you get, that's the most important thing. A power of a telescope means nothing. I mean, if you magnify a crappy photo, it looks like crud, right? So the most important thing is to get that light gathering power. We also plan to arrange visits to observatory. UW Stevens Point has a small dome there. Every Monday night, it's open up to the public during the school year. And they have a great planetarium, although their projector just broke down. And the new projectors for domes are pretty nice. And then we have other problems with Yerkes, programs with Yerkes down in South Madison. And they have the largest refractor in the world. It's like 40 inches. And they don't have it running yet, but they're working on it. But that was built such a long time ago that newer telescopes that we have now are just about better. But the historical value of going to an observatory like that's a lot of fun. Our club works with the Jet Propulsion Laboratory, NASA's Night Sky Network, which I had a part in developing. It's a program to help astronomy clubs all across the United States, which there's about 600 of them. The Great Lakes Planetarium Association, which is involved with building planetariums, and the International Dark Sky Association, which Madison just adopted lighting regulations that are recommended by the International Dark Sky Association to help make lights downcast instead of broadcasting up into the sky. One of the main aspects that I've been concentrating on, though, I found out a lot of people coming to star parties have these wild notions about how everything's put together. They think stars are in the solar system. They think that the seasons are due to elliptical orbit. Many other misconceptions are out there. So we have scientist-tested activities from NASA that develop activities, and we go to schools or public programs that we make sure we try to convey information that helps dispel those misconceptions. We have many upcoming programs. We've developed a 3-week beginners stargazing program. It's going to be held at the Iron University, FE University up in Hurley next month, actually this month. It'll start on March 21st. You can sign up at FE University. And it's not just stargazing, though. It's like an astronomy 101, but hands-on. So we'll show you the theory of astronomy, but then we'll show with the telescopes and other activities that when you go out and look at the night sky, you'll be able to relate to what you're learning. Then we'll follow it up with a field stargazing trip afterward with actual telescopes. In June, we're going to have Dr. Trey Wenger from the University of Wisconsin-Madison talk to us about star formation in the Milky Way galaxy. And then in June, we're going to have in July, we're going to have Dr. Sebastian Zamfir talk to us about exoplanets. On June 21st, summer solstice, we'll set up our solar telescopes to look at the sun during the day. And then in July and August and 8th, we'll do the same kind of stargazing classes at Discovery Center. Now, because of daylight savings time, it's really tough to do star parties here in June and July and May because it doesn't get dark till 10:30 or 11. So we'll do daytime programs, but fortunately, some of the best planets to look at are Jupiter and Saturn, and they're going to be available in the fall. So come August, September, October, that'll be the best time to see those planets. We're also going to be at the YMCA to do some kids programs there, and a public star party in Rhinelander, and another one at Discovery Center. So we are the Northwoods explorers of space and astronomy. So we also are involved in space. My partner, Bob Kruger, is retired lieutenant colonel in the Air Force, and he just got his degree in master's in space science, and he wants to build a space and science museum at the Lakeland Airport, and he wants to start a company to mine the moon. So we'll see what happens there. Now, I personally want to build a planetarium and an observatory somewhere up here. It's a big challenge to set our telescopes up, pack them up from our house in our car, and go set them up in the field, try to get everything aligned, get it all set up right, and show the stars and pack it back up. If there's any chance of rain, our telescopes hate water. I mean, the optics are just terrible. So we're really reticent to be able to try to do this if the forecast is iffy. But then that's the hardest thing in my job is whether to call off a star party or not, because if the rain clouds are threatening, do I invite all the people out there? Do we keep that commitment? And if we set up everything, it takes us 10 minutes to shut everything down with a rain cloud coming in. That's not enough time. So we got stuck last year at the Monaco Winter Park, and it hit us, and it cost me over $800 to get my mirror and my 12-inch reflector resurfaced. So, if we had a public observatory with not the typical dome type, but with a roll-off roof, they're much more economical to build and so much more convenient, because then you could have a star party every month or every weekend, and if it's cloudy, you don't do it, but if it's like iffy, you can still do it, and if the rain comes, you just close the roof. So anyway, backtracking again, right now I'm going to touch on a few activities that have been happening in space, and then I'll talk a little bit about what's happening in the night sky. So first, I want to mention that I'm sure you guys heard NASA had this DART mission to deflect an asteroid. I don't know if you've heard about that or not. There's a big threat. All the big asteroids that are planet killers have been pretty much mapped. But the smaller ones that are city killers have not. Especially if they're coming around from the sun, we can't even detect them. Well, fortunately, NASA decided to send up a rocket to see if they could impact an asteroid and change its orbit. They didn't know if they'd split it apart, make it 1,000 pieces. That used to be the classical thought about it. Well, it turned out it was a great success. They were able to change its orbit, and so that's a good thing. So now JPL and NASA have a planet defense section of their group to help deflect asteroids, to help identify them so we all can be safer. I don't know if you heard about the Chelyabinsk event that happened in Russia a few years ago. Over 1,500 people had to go to the hospital because this asteroid that came from around the sun, they didn't even detect, they didn't even know about it, it ended up in the sky. It was in Russia, and in Russia they have a corrupt insurance program, so everybody has dash cams on their car. So thousands of people caught this image of this asteroid coming in the sky. And it blew up in the atmosphere at 200,000 feet up in the air, and eventually landed in the lake, but had been disintegrated. But everybody saw this big, bright flash of light, so they went to their windows to see what was happening, and they didn't hear anything. And all of a sudden, kaboom! 3 minutes later, the sound wave hit, and it broke all the glass, shattering it into everybody's faces. And so everybody got all these little cuts on all their body and faces, and so nobody died from it, but it broke down a few buildings and stuff. So they are out there. So that's good that they're doing this. Next, I'm going to talk about the Artemis program. Excuse me. I'm sure you heard about it. They did a successful unmanned orbit around the moon and came back in their huge rocket, the biggest rocket ever, Space Launch System. In 2024, next year, they plan to send the first woman and man around the moon and come back. They're not going to land on it. At the same time, SpaceX has been charged from NASA to develop their huge Starship. I'm seeing videos of that. They're going to try this month, they hope, SpaceX hopes to launch that in orbit around the Earth to prove its function. If it's successful, then Elon Musk with SpaceX is going to send up cargo ships with fuel to go in orbit around the planet Earth in preparation for Artemis 3 in 2025 that's going to send people to the moon. And what will happen is that NASA will send their Orion spacecraft on Artemis rocket to the moon with people on it, and then Elon Musk's Starship is going to go to the moon, and it'll be the shuttle when Artemis is orbiting the moon. The SpaceX Starship will take the people, will mate with the Artemis rocket, and take them to the moon. They'll be there for a few days, and then they'll come back to Earth. Well, that Starship from SpaceX will never come back to Earth. It'll be a shuttle between the moon and the Artemis missions. By 2027, NASA hopes to build a gateway, like a spacecraft, which is going to be like a space station going around the moon, and that'll be there permanently, and that'll be the docking thing. So Artemis will launch from Earth, it'll connect to the gateway, and then from there, the Starship or other vendors that they're contracting out will be the shuttle between the Earth and the moon. Now, there's a big problem with space travel, though. We're all talking about the moon. People want to go to Mars. You have to learn how to live on the moon first. Where the International Space Station goes around planet Earth, it's within a couple hundred miles, and they're not in the radiation area. Our magnetic field around planet Earth is like a force field. It protects us from all the radiation, cosmic rays that's coming out from outer space and our sun. from outer space. It's coming from supernovae and other galactic explosions that are creating these highly energetic particles that are very deadly to people. So when you go beyond the orbit of the International Space Station away to the moon, you have to get past the Van Allen radiation belts, which are highly radioactive. That's where all the radiation that's been kind of captured by our magnetic field protecting us on Earth. But when you have to pass through that, that's really deadly. So if they can get past that, once they get to the moon has no atmosphere. And Mars has just only 1% atmosphere of Earth. So either case, it's really a tough situation. And on the moon, the longest astronauts have ever stayed there before from the Apollo program has been 12 days. If they're trying to stay there for longer than that, that's going to be a big problem because the galactic cosmic rays that are coming in have no shielding to decay them or to prevent them from hitting the moon. So it comes into the moon, it's hitting the regolith, the soil on the moon, as they call it, the regolith, and it decays and creates another nuclear reaction in the regolith. And so you have these neutrons coming up that are radioactive from the soil of the moon, the regolith. So you have both the galactic cosmic rays coming in from top as well as the stuff coming from the soil. And then if you have our sun, if it were to have a particle event, as they call it, which one happened in 1972, and if anybody was here during the summer in August of 1972, the aurora was right above us. It was like a tie-dyed T-shirt above us. It was incredible. And it's very deadly for astronauts, though. Fortunately, that was in between Apollo 16, which was in June, and Apollo 17, which was in December, so they missed August. Had they been there when that happened, they would have been dead. So it's really dangerous to go out there. They're talking about Artemis. It's a big enough craft that they're going to carry a special shielding thing. So if they have a particle event from the sun happen, they can crawl inside this thing and protect themselves for the 2 or 3 hours or 24 hours that that's going to occur. So it's really risky going out there. So there's a lot of things that have to happen. Now, fortunately, there's some other new developments that have just occurred of like I mentioned, our Earth is protected by this magnetic field. So they're thinking about building electromagnetic generators on spacecraft to create their own force field around them. I mean, isn't that cool? I mean, you could just create your own little bubble to keep you safe from everything, and maybe that's the future. So that's a little bit about Artemis. Boeing is also going to test their Starliner spacecraft next month. They've been trying to do this for 5 years. It's going to be like the Dragon spacecraft of SpaceX. It's just a shuttle between Earth and the International Space Station. The Webb Space Telescope, the James Webb Space, that's just a fantastic instrument. It was so scary when that thing launched and it was being deployed. These people were working on it for 15 years, right? Your whole life, career was on this, and if something didn't work right, that's almost true with every NASA mission, though. And this was a combination of both ESA and the European Space Agency and the United States. But the discoveries that it's made is just incredible. So the James Webb Space Telescope has special detectors to detect the infrared light at the very far end of the spectrum. And when you're trying to find things way far away, since the universe is expanding, everything is receding from us, all the light gets shifted towards the red end of the spectrum. So 3 of its 4 instruments are for the far infrared, and the other one's for mid-infrared. And so all the pictures you see of white light, they've all shifted it for our viewing pleasure. That's not how Webb sees it. But then again, our brain does the same thing with color, right? There's no such, all the colors you see are because of our receptors in our eyeballs, right? We have cones that are sensitive to the red, green, and blue, and our brain interprets that as color. So everything's false color. But the James Webb Space Telescope, because of its instruments, though, can look farther than Hubble can, and it's detected galaxy evolution faster than we thought it could be. So scientists aren't really sure how the universe started. They think there's this big inflationary period, and then it took a while for galaxies to form. Well, Webb just proved all that wrong as far as the galaxy part. They're finding these large galaxies forming right away. And they don't know it's because the dark matter or the dark energy or black holes are starting forming, so that's a new mystery. They also detected incredibly rich chemistry in the dark, cold clouds of nearby objects. It turns out that when solar systems form, if there's a lot of hot matter, it's going to repel itself. For a star to form, you have to have things condensing. And so for it to come together, it has to be really cold. And the Webb Space Telescope, because it can look at the far infrared, because of its shielding, can look at that very low temperatures. And when it looked there, it found all kinds of prebiotic chemistry going on, which proves that when a star forms and it creates this dust cloud around the star that's going to form into planets, it has all the material to support life. We don't know how life starts, but all the evidence is there that it has all the chemistry to make that happen. So that's pretty exciting. Unfortunately, it keeps on getting hit by meteoroids, and so they're hitting the mirrors of the Webb Space Telescope. And so what they've done, they're at a Lagrange point 2 beyond the moon, about 1 million miles from here, where the moon's only 250,000 miles away. And so it's kind of orbiting in a circle. And so what they've done is that they're only going to change their observing pattern to look backwards. When you have a meteor shower here on Earth, the best time to look at it is after midnight. Why is that? That's because the same kind of thing, when you're driving down a highway, the bugs hit the front windshield. They don't hit the back windshield, right? So the same thing with our planet Earth. When you look for a meteor shower, when the Perseid meteor showers happens this August, you want to look after midnight, because that's when Earth, when you're looking above or towards the east, that's when the Earth's turning into its orbit. So you'll get more matter coming into it, as opposed to, you drive down the highway this way, there's going to be no bugs on your windshield. So the Webb Space Telescopes changed their observing pattern to do the same kind of thing, to look behind. It's a clearer view and safer for the craft. JPL still has rovers on Mars. They're hunting for evidence of microbiological life. Water is the holy grail for NASA. Wherever we find life here on Earth, whether it's in the volcanic vents at the bottom of the ocean or in the bottom of a nuclear reactor or at the bottom of the Yellowstone pits, there's always this liquid water involved, though, still. So they think that water is key to life. That's the main mission for NASA if they're trying to find evidence for life. And on Mars, they're finding water underneath the soil. So that's trying to see if life ever existed there. And scientists believe that Mars was more Earth-like in its early beginnings of the solar system. Earth was inhospitable to life for the first few billion years, and they think that Mars was more compatible. If you want to know information about the Webb Space Telescope, you can go to their website, just webbtelescope.org. So the sky tonight and beyond, I don't know if it's still out there, but there's going to be many opportunities to see Venus, and Mars is up in the sky right now, and it's kind of fun. If you look out tonight, you'll see a triangle of 3 red objects. Mars will be on top. If you find the Orion constellation, Betelgeuse, which is a super red giant that's about ready to blow up, it's about 800 million light years away, so we don't know, 800,000 light years away, so we don't know if it's blown up yet or not. And then Aldebaran, which is in Taurus, they form like a red triangle. You get 2 red giants and Mars, so it's kind of pretty. I use Stellarium, which is stellarium.org. You can go to there and you can download the Stellarium program. It's real easy to use, it's free, and you can find out where things are in the sky at any time of night. Our website, the northwoodsexplorers.org. If you go to the Sky Tonight tab, we have many links to go look at to find things, as well as the weather forecast hour by hour to find out when it's going to be really clear. I mentioned the Perseid meteor shower. This can be great this year, if it's clear. It's going to be August 12th, which is a Saturday, to August 13th, which is a Sunday. But more importantly, the moon is not going to be up. It's going to be a small sliver of a waning crescent around 4 o'clock in the morning, and that doesn't even count. So when you don't have a moon that's bright, the sky can be really dark and you can see many events. And it's the best show of the year, typically. They're typically really fast, but I recommend everybody trying to get out there to see it. If it's clear here and you're signed up to our list, we'll let you know what we're going to do. We're going to find a location that's wide open where you all can camp out and have a good time and try to watch that shower. Should be a lot of fun. There's no big eclipses happening this year, other than an annular eclipse in the western United States, southwestern United States in the fall. But next year, April 8th, 2024, make your plans. If you've never seen a total solar eclipse, I mean, we came here on our trip to move here in 2017. We were camped in Wyoming to see the last one. It is just incredible. I mean, it's a life-changing event. I mean, I know I have friends that will travel anywhere on this planet to see one. and the sky darkens, and all of a sudden the wind picks up, the temperature drops 20 degrees, and all of a sudden you can see stars around the sun. The moon's blocking out the sun, so you can't. And if you have image-stabilized binoculars, which I have 2 sets up here, they're kind of pricey, but they take out all the vibration, and they're excellent for viewing. So I highly recommend that. It's going to come up through Texas, go through southern Illinois, and then go out through the upper states of New York and Maine and out to sea. The trick is, when you see one of these things, is to stay mobile, because if it's cloudy in one area, you want to travel to another area to catch it. And the eclipse only lasts 3 minutes, which is unfortunate. Mars is up now till the end of July, and then Saturn will start coming up in July, and Jupiter will start coming up in August. And those are great planets to look at. Now, the rings of Saturn, they're on a many-year cycle. Saturn has almost a 30-year orbit, and its position in its orbit to our position in our orbit makes it difficult sometimes to see the rings. Right now, they're pretty good. In 2025, though, they're going to be edge-on. They'll disappear. And then in 2032, they'll be at their maximum amount. They were last at their maximum amount in 2017. So it depends what time of year they are. Now, Jupiter is on like a 10-year orbit, so every year of Earth that we go around the sun, those planets advance a little bit. So I mentioned that Saturn will be available in July, and Jupiter in August. That'll shift a little bit later each month over each year. And that's good, because here up at this latitude, the ecliptic, the path that all the orbits are in our solar system, as we view it here, will be higher in the sky at nighttime in the wintertime. So as these planets march in their progression around in their orbits, and as we look at them in the fall and winter over the next 5-6 years, it'll be a great time to look at them. And last year we had 10 star parties in August, September, and October. Many opportunities. We're at Monaco Winter Park, Monaco Library, Discovery Center, out at Rhinelander. So sign up to our list, and that's a great time if you want to see Saturn and its amazing rings, and Jupiter to see one of its 90 moons, or however many moons it has. It's incredible. The sun also, fortunately, is headed towards maximum. It's on an 11-year cycle, so for a few years it goes up and then it goes down. When it has more activity, more sunspots, it also has more aurora. So if you sign up to our list again, we've arranged with the Monaco Winter Park to open up the gates at night on a moment's notice if the aurora is going to be hitting. In fair weather, we can't go up there because of the snow right now, but in fair weather. And the overlook in Monaco Winter Park looks north, and you can see just for miles. And that's a great place to view aurora. So we hope to see some more. But not only that, through our solar telescopes, which look in the hydrogen alpha band, you'll see more prominences on the limb of the sun. And I've seen them lift off and just disappear into space over a period of 10 or 15 minutes. And it's just kind of fascinating to look at that. So one little comment about our activities. I found this little parallel. I know there's a lot of hunters up here, right? So in our language in astronomy, it's very similar. So I heard there's many hunters. It's a challenge to get everything right, to set up your telescope. You're trying to find your targets. You're trying to catch them in your telescope. It's all the same kind of process, except all you're trying to do is catch that light. And when you catch that light and you finally see it and you're lined up right, it's fascinating. It's not an easy thing to do. But I do think that the best way to start out is with binoculars. Don't go out and buy an expensive telescope. We have telescopes you can borrow from us if you want to learn how to use them, or just come to our star party. That's the best thing. You don't have to worry about anything. You just come up, and we have the right eyepieces that make it easy to look for the first-time viewer, whether you're wearing glasses or not. It's a lot of fun. Plus, we have activities. We usually precede our star parties with some kind of activity to teach you some kind of simple process about astronomy. And because we're involved with the Night Sky Network, all our activities are scientist tested, and we try to really convey the right principles that will help you understand. So hopefully you'll be able to walk away with some kind of understanding that you stay with. And it's great for kids, and we've had one parent come up there. I used to think that children that are under 7 have a tough time just looking at one eye and closing off the other in an eyepiece. Well, we have bino viewers where you can look through both, but then you have to get the interocular distance of their eyes correct, which is a challenge because you're not them. You have to estimate it, and it takes a little bit of trial and error to figure it out. This one parent had a 3-year-old, and she just lifted up the child and said, "Look," you know. And it was the moon. It was a bright object. We tried to plan our events so that there was something bright and easy to see, and she saw it. And that was the youngest, 3 years old. I never thought it would be possible. So it's a lot of fun. I also have up here, for an example, some cosmic debris. This is a 19-pound iron meteorite. You're welcome to come up here and inspect it afterwards. This is older than planet Earth. It's 95% iron, 5% nickel, and some trace elements. It was a product of a large rock that broke up in the atmosphere that hit Earth about 5,000 years ago, and it spread out over a field of about 20 miles by 10 miles. It landed in Argentina, and they discovered it about 1,000 years ago, and all the big rocks that are floating on top were captured by the kings or whatever you want to call them back in those lands, back in those days. I got this one from a meteorite dealer in Alameda, California, in the San Francisco Bay Area, and he had the smart idea many years ago. He bought a lot of state-of-the-art metal detectors and arranged for the government of Argentina to go down there to hunt for meteorites. And his deal was with the government that he'd give them half the take and pay people from Argentina, give them salaries to do this 1-month hunt. When I went over to his house to see his townhome, to see his meteorite collection, to buy one of these from him, I don't know where he slept. The whole place was full of meteorites. And he had one room for the 1-inch to 3-inch ones. He had another room for the 5-inch to 10-inch ones. Then he had another room for these were. And then he had this one big rock sitting on this bank safe. And I'm going, "How did you ship that here?" And he goes, looking at me like I'm stupid or something. "The bank safe." I mean, that was the only thing that's strong enough to be able to hold that meteorite. So there's a lot of fun. So this is called Campo del Cielo, and there's many other meteorites that you can find. A lot of these meteorites, though, have the early history of our solar system when it formed. They're the cosmic debris after our star formed and all the planets formed. There's a lot of these still floating around and hitting our Earth, and you can find them or purchase one and stuff. Some of them have actual volatile chemicals in them too, and they're prized by scientists. So if you ever do see a fall or something unusual and catch one, contact a scientist and get it to a lab right away. There was an old movie, I forget what it's called, that talked about one of these things hit, and they were really worried about it causing viruses coming out of it or something like that. But it turns out these things are out in space, and they've never seen an oxygen environment. Our atmosphere is really oxidizing, right? So it really eats them apart right away. So a lot of them are prized and a lot of fun to collect. So that's pretty much it for my little introduction here. Thank you very much.
Great. Well, let's take some questions. Carol has a microphone, so just raise your hand and ask a few questions.
Don't be shy.
Don't be shy.
There's been a lot of talk in the media about mining asteroids and mining the moon and so on, which seems to me like centuries away. But do you think the moon's going to be divided up by countries that want to go there? Like between China and the United States, are going to have areas territories and possible warfare and everything else?
So the moon itself has a limited value, I think, in a lot of mining activity. I think most of the effort will be to try to use that for manufacturing to build their own space bases and the like. They need to provide shielding. The concentration effort is going to be that so they can even exist there. It's a highly radioactive environment, and it's very dangerous. The richer, more valuable finds would be the asteroids. And there's a lot of effort to figure out how you can capture an asteroid, and NASA's been spending a lot of time on doing that because you can find large amounts of gold and silver and maybe even diamonds in this material. All the matter we see here, you and I and everything, is all made by stars. Inside the stars, they're from stellar evolution, the highest you can get is iron. That's why there's so much iron. And all the iron that's up here, Iron County and Iron River and everything, that's all come from stars from before. Our sun is a second or third generation star because you can find metals in our sun. The Webb has discovered, when you look way back in the distant beginning of our universe, they're trying to find what they call population 3 stars, the ones that don't have any metals in them. Those are the ones that are very first stars that only have hydrogen and helium. The ones that are later are the remains of other supernovae that have been blown up and then recoalesced to build a new solar system. And so we're second generation at least here, all of us. And so the leftover material that's in our solar system, the asteroids, could be very valuable, could have a lot of useful material. There is one aspect of the moon, though, it could have helium-3, and it can't be found here on Earth. And helium-3, the way I understand it, could really shortcut the process to making nuclear fusion a reality.
I have an online question. They ask, I recently heard that the Webb telescope identified a galaxy that is much like our Milky Way. What about them is similar, and how do galaxies differ from one to the other?
Oh boy.
In a nutshell.
Well, the truth is that we're trying to figure exactly that out. There's no real, especially after it discovered these galaxies, only 300 million, 400 million years after the quote-unquote Big Bang. It really wasn't a bang, it was like an inflation period. But those galaxies really surprised the scientists, and so they're trying to rework their models to figure out how do galaxies really form. And so that's a really active area right now in the science to understand that. The way a Milky Way galaxy is formed, they think, was through billions of years of things slowly coming together. And these galaxies that are already formed 13 billion years ago really surprised them. So mystery still stands.
All right.
Difficult to even phrase this. Can you give me some idea of where we are in the big picture if we see galaxies moving away from us at greater than the speed of light? Where are we in relation to the center of the Big Bang?
Well, when the universe started, there's a period of inflation, and for our universe, we have a thing we call the observable universe. So where we are here on Earth, what we look out, the farthest we can see is the light that's started way back when the universe started, 13 billion years ago. So the farthest that we can see is 13 billion years ago. But if you were to go somehow be able to talk to somebody that's, let's say, 10 billion light years from here, their observable universe would be different than ours. It would be like an Oort diagram. It would be overlapping circles. Their observable universe and our observable universe, we have intersection section, but they could see much farther that way than we could see that way, but we could see much farther that way than they could. Does that make any sense? No. Well, it's like a rubber sheet, and the whole thing's expanding. Right. So if this person over here can only see 13 billion light years around their circle, this person over here can only see 13 billion light years around their circle. So like a Venn diagram, I guess. And so they can see, they're 13 billion years that way, but they can see is farther than we can see.
I understand that. I think we have any concept as to where we are in the big picture. Where were we from the epicenter?
Everybody's in the center. It's infinite. As far as we know, it's infinite. And if you were in the inflation period, when it was only much smaller, it was still infinite. Wrap your head around that.
So,
There is no center. There's no center of infinite. But your center sitting there is different than my center sitting here.
so I understand that there are more and more satellite constellations being launched and built upon out in various orbits. And I wondered if you first look at any of those with your binoculars or your telescopes, if you watch any of them as they come into view and go across the sky.
Satellites are a nuisance.
And that was part of my second question, is that are you finding them a nuisance and are you worried about them getting in the way?
it's going to get even worse. Elon Musk is going to do their Gen 2, which are much wider. They're going to try to cover a larger area with more power and try to get military signals going and other things and TV stations and video going instead of email. So that's a big problem. And so is light pollution. There's many challenges. Now, fortunately, for most casual observers like us, it's not going to be an issue because when they're going to be bright is right after sunset or right before sunrise, because our shadow in the middle of the night, our shadow of the Earth's going to have a clear view. All those will be dark. The difference being the professional astronomers, people already got fooled. They thought that they found the farthest star ever, this one, and they did a whole paper on it, and it was being peer-reviewed. In the process of being peer-reviewed, they found out nobody else could verify it. And it turned out they got the glint of one of SpaceX's satellites involved in the image. And so it can interfere. So now they understand that, so they try to take that into account. But yeah, there's a great effort, and Elon Musk has tried to do darkening things and stuff, but it doesn't really matter. I mean, the stuff's in the way. And with Amazon now, Jeff Bezos is going to start launching a whole new constellation too. China's going to do the same thing. India's going to do the same thing. Russia said they're going to do it, but they can't afford it because they're just making bullets. But
A question back here.
If we were standing on the surface of the Antarctica tonight, looking up at the sky, what would we see?
in Antarctica, well, you'd see stars if it's clear. It would be a better view because the atmosphere is thinner, because our rotation of the Earth bulges our atmosphere. At the equator, it's heavier and there's more water vapor, and that is just like satellites, water vapor is in the way of being able to have a clear shot to the sky. In astronomy, you have a thing called seeing, which is a different kind of term. It takes into account wind, humidity, turbidity in the atmosphere, the trade winds, and whatnot. So if the stars twinkle a lot, that's because there's a lot of wind and it's lousy. You look at a telescope and a star is bouncing all over the place like this. You don't want to see twinkling in the sky for telescope viewing. As far as what constellations you'd see, it'd be completely different. The Indian tribes in the north, Dene, they view the sky as one constellation because it's pretty much the North Star is at the very top of you, and you have the Big Dipper going around forever, so they just see one structure. They don't see a season of constellations like the zodiac we do at the more southerly latitudes. In the Antarctica, there's no, in the north here, we see Polaris, which is 1 degree away from where our Earth's axis is pointing toward. That's just a happenstance. It's just an arbitrary thing, kind of. In 23,000 years, Vega will be our North Star, or closest to our North Pole, because our Earth spins like a top. And so over a long period of time, those things shift. In the southern hemisphere, there's no star that's in the vicinity of the axis of our Earth that's pointing toward. So you don't have any reference like a North Star in Antarctica. Does that answer your question?
Yeah. What about, do they have constellations? Are there constellations that are identified in that?
Can you repeat that?
And is the Southern Cross a stable formation?
Yeah, the stars in the night sky.
Can you repeat that? And we'll wait for the mic when we go around, but can you repeat her question?
Oh, she was asking what would the sky look like in Antarctica.
No, the second part just now.
Oh, whether you'd see the Southern Cross, would you see the same constellations, I think?
And is that a stable, like the North Pole?
Would it remain in the same spot in the sky? Is that what you're saying? No, it would rotate over the axis of our spin of our planet. And constellations are all are made up thought of organization of points of light in a 2D map in a 3D world. If you took a spaceship out into space, all those stars would have different formations, right? Some are closer to us, some are farther away. And I should mention also, that's why binoculars are a great way to start in astronomy, because there are many dimmer stars that are closer to us than the bright stars you see in the night sky, but you can't see them. okay? Because the bright ones show up, and so anyway, if you took a spaceship out there, the whole pattern would change. You know, if you look at the Big Dipper, some of those stars are going together, but that's a rare thing. We're kind of going. The Big Dipper is going to go in the. It takes about 100 million years for us to rotate around the Milky Way galaxy, our solar system, and Big Dipper stars are going to be going in front of us as we go through them in a few million years. Most other stars, they'll just kind of be completely different makeup. And in fact, you know, there's 12 constellations in the zodiac back 2,000 years ago. Well, now there's another constellation in the middle of it. Every 50 years, there's a different epoch that the star catalogs are based on, since the stars all do move, but slow by our short lives appear. So we have to, right now we're working off the 2000 epoch. It had changed. The previous one when I was growing up was the 1950 epoch.
What is the best way to get an advance notice a couple of days of a Northern Lights phenomenon?
Well, sign up for us on our website. Short of that, spaceweather.com is a NASA website, spaceweather.com. And you can sign up for free there, and they'll give you notices of when the higher probability is. A warning, though, I get over 20 emails a day from them, and it gives me an update of what the energy is coming from. And so I usually wait for another kind of notice on my phone when I'm signing up for another service that I pay for that gives me the notice, Southwestern SWPC, I forget what the name of it is. But all those links are on our website. If you go to the Sky Tonight, you can see the link for finding when aurora is going to happen. It's one of the tabs.
We have another online question. Are you a member of an international amateur astronomers organization? If so, what sort of cooperation does that organization facilitate?
We're members of the Night Sky Network, which is the national organization, the Astronomical League, also, which is a great organization. And both of them offer, sky tips for looking at things, give you different access to scientists to look at different stuff. The Astronomical League has a whole program on challenging yourself to find, for example, all the open clusters in the night sky, or to find all the Messier objects, or to find all the different galaxies. And they have a book, and they give you a list of what to find, and it's kind of a challenging effort. And sometimes you have to do this throughout the whole year. But when you do accomplish it, you get a little paper certificate that, I did that. I'm a galaxy observer, I'm a nebula observer, that kind of thing.
We have another question from behind the bar.
Okay.
With all the satellites that are in the sky, is there any forward motion in cleaning them up once they've done their job, or getting them out of the sky? Or is that?
There's a couple of private efforts that are building spacecraft to go capture other ones and to decommission them. Most of the time, the hope has always been is that they'll just decay and burn up in our atmosphere after they don't do anything. And unfortunately, we had a couple of bad actors on our planet, and they decided to blow up their satellite to see what would happen, and created tons of debris out there. If anybody's seen the movie Gravity, though, that's full of misconceptions, so I advise against getting any kind of science information from that movie. There is just no way that if you're, to be in orbit, on the space station, they're not really out of gravity. I mean, the gravity is 80% of what it is here on Earth. It's just that they're falling. It's like going in a down elevator all the time, right? So they're in motion, and most other things are in motion on the same rotation. So usually the things that harm you are things that are coming from outer space, that are being drawn by Earth's gravity. When you look at the moon, especially with binoculars, you see how it's so pockmarked with craters and everything. And you look at that and you go, that's amazing. Well, it doesn't have an atmosphere, so there's no erosion taking place. So that's a historical record over 4 billion years of activity on the moon. Well, the moon's about 1/4 the size of planet Earth, and we have a bigger gravitational pull than the moon. So if it's 1/4 the size of us, and we're, 20 times more massive or something, we should have 20 times more craters here. You just don't see them because of the activity of our tectonic plates and the erosion of the wind and the weather and everything else that we have from our atmosphere. And so we're hit much more than the moon is. I don't know if that answers the question, but get the idea.
So whoever asked about how to look up the aurora, there's also the Soft Serve News website that gives you the right at the moment aurora update. Right now, our aurora is active.
Good.
So what is the difference between, what is the definition of the KP number? They always use a KP number, and right now it's 3 active.
Right?
And then usually when it's storm, it's KP5. You know,
Yeah,
basically.
and
So
you have
what
to
is
get KP7 or higher usually to really see a good deal right here. It's just another index of measuring how active the energy from the sun is. There's many factors that come into play. Usually, if you have an outburst from the sun, it's like a quarterback passing a football to a receiver. It takes about 2 or 3 days to come here, the active energy from the sun, and if it has to be at the right in the solar plane, it has to be where we're going to come and intercept it. But there's other events that just happen from the solar wind that's always active, and it turns out during the equinoxes, we're more aligned magnetically with the sun to be able to receive energy. So here in March and then later in October, it'll be September, October, are usually the best times for seeing aurora. Of course, for me, I've all seen lots of it in the summertime, and any time of the year is good whenever it's active. The thing is, though, on any of those indexes, I found that no matter what it says, if you have up here, especially in the Northwoods, where it's cloudy often, is that whenever it's clear and you're up, take a look. And the best thing to do is use your phone camera, because it'll see better at the low end of the frequencies of light than our eyes can see. And plus, it'll take a time exposure where our eyes are in real time.
Yeah, that's great. I just have another follow-up question, though, too. Does your group do anything with like navigating by the stars? Because I lived out in Hawaii, and they are very actively teaching youth, navigation by the stars, which is something that humans did for so long. Basically, we've just lost that. But it was so cool to go out and see how they actually still do use, without any instruments, just navigate by the stars.
Yeah, that's fascinating. My partner, Bob Kruger, he used to be a lieutenant colonel navigator on the KC-135 tankers, refueling other planes and stuff, and he has great knowledge on how to navigate by the stars. For me, I use Google Maps when it's available. I know where, if I can find the North Star, I use that, and if you're in the Northern Hemisphere, that's great. If you're in the Southern Hemisphere, it's more tricky, like I was mentioning this other lady about in Antarctica, because you don't have the reference of Polaris. But here, it's so simple because the Big Dipper points right to it, and it's real easy to find.
Question over here.
I'm wondering about the radiation level on the surface of the moon and future habitation, and how quickly the radiation falls off as you go below the surface. Why couldn't we build a moon home rather than an Earth home? Just build a structure and pile up a bunch of moon dust over top of it as a radiation shield. Just how far does it?
There are evidence of lava tubes and the like on the moon from long ago activity, and that's a prime candidate for habitation. But going down deeper sounds like it would be a logical thing to do. We've never had any spacecraft on the moon, though, that dug deep enough to find out. In fact, it was a Chinese craft that just recently first measured the radiation from the moon. We had hints from it from the Apollo mission, from the sensors we put down there. And there was another craft put down there, I forget the name of it, a few years ago. But it didn't really do as much as what the Chinese spacecraft just recently did. So they had the first mission to the moon to measure the radiation from the regolith. And we haven't done anything like that. The hope is, the Artemis mission is to duplicate what the Chinese have done and to deploy some of those instruments to find out what's down deeper. Of course, their goal is to go at the south pole of the moon or the north pole, where there's going to be water in the craters that are permanently hidden from sunlight, so the waters remain, because they want to be able to use that for the resources. They can split the hydrogen for fuel and the oxygen for the oxidizer as well as for breathing.
Question back here.
Any guess how much of a layer of soil, moon soil, you have to significantly cut the radiation?
No.
Back here.
He wanted to know how deep. I mentioned that the regolith, the soil of the moon, is radioactive from being bombarded by galactic nuclear radii, and the same thing from the sun too, from the solar outbursts and particle events. And he asked, does that exist if you dug down deeper? If you wanted to build a shelter to protect yourself, could you use the soil that's down deeper to protect you from the radiation? Is that right? That wouldn't be any good because it's all full of neutron radiation, the stuff that's all around you. Water, anything that's full of hydrogen, water, some plastics, can do a good job. They've thought of some other things I don't want to mention right now, but to help shield yourself.
Question back here.
You briefly mentioned dark matter and dark energy. What are the best estimates to the total mass that would make up in percentage of the known universe? Because it can't be detected directly, and how do we detect it indirectly?
In the case of dark energy, that was discovered, the energy is the propulsion force that's moving everything apart. And that was discovered by Alex Filippenko and UC Berkeley and a bunch of other scientists who were trying to measure type 1 supernovae. To measure distances in the universe is really tough. Things that are close, you can use parallax. Every 6 months, our orbit, we're 93 million miles from the sun, so we're 180 million miles from June to December, or any 6 months apart, right? And so you can use parallax. That's only good out to a certain distance, and the universe is so big, they needed some way to measure faraway things. So they can use the spectra. They found there's this one type of explosion, type 1A supernova. It's usually when you have a binary star and a bigger star is being sucked up into this binary star, and it comes to a point where it blows up, and it's a common thing that happens. There's a lot of binary stars in our universe. And they have the same light signature. So if you can use the brightness of that light signature, you know it's the same kind of event, then you can measure the distance of it. So Alex Filippenko says, let's do an exhaustive study and measure all the type 1A supernovas around and see if we're collapsing or not. Because the theory back then was that we're steady state, and we're probably going to be, all the gravity is going to be pulling us back together. So we had a big bang and pushes all apart, and then all the gravity is going to pull us back down together again. It's going to rinse and repeat kind of a thing. And to their surprise, his first finding, he couldn't believe it, so he sent it out around the planet. He said, all you other guys, let's do the same study. So observatories all around planet Earth for 3 years, the same study, and they came to the same conclusion. The universe was accelerating apart. And they have nothing to account for it. And they still have nothing to account for it. So they call it dark because they don't know what it is, but it's energetic because it's pushing everything apart. And so all the theories today I was talking about before about this big rubber sheet that makes it appear that things are moving faster than the speed of light, but they're not themselves faster than the speed of light, but from our point of view they are. They'll go out of view. So over 1 trillion years from now, we'll see less in the universe because it'll go beyond our observable reach. So that's dark energy. Dark matter was discovered first by by many different scientists, but the first by this woman, physicist, that in our solar system, for example, Mercury is really fast, 88-day orbit, Earth's 365, and like I said, Saturn's 30 years. The farther out you go, the slower things orbit around because of Newton's laws and Einstein's. So they're looking at galaxies that rotate. So she was studying galaxies, and she's wondering, why are these stars way out the edge of the galaxy moving at the same speed as the inner ones? It's like a bicycle wheel spoke. That shouldn't be happening. It should be the stuff that's farther out from the center of the galaxy, which has more mass. There's a black hole there. There's more concentrated matter. So the things that are near it should be going faster. The things farther away should be going slower, like in our solar system. He found out they're going the same speed. The only thing you can account for that, if there's some other kind of dark matter there that's supporting it, the structure must be much larger. Then Hubble saw these two colliding galaxies that went past each other. and they left this big blob of stuff in the middle they couldn't see, but because of gravitational lensing, they saw farther off distance things that show there's this big mass in between these two galaxies that they couldn't account for. And they did some more measurements, and they found out that must be dark matter. And that was the first real observational proof that it existed. So there's been a couple other studies that have suggested, well, maybe black holes are somehow contributing to this and whatnot, but still, it's still a big mystery. As far as to what percentage of the total universe, well, everything you see, everything we observe, accounts for about 4% of the universe. The rest of it is dark matter and dark energy. And since from Einstein's rules, energy and matter is interchangeable, you just combine dark matter with dark energy. And so 96% of the universe is this mysterious stuff. We have no idea what it is.
We have a couple more online questions.
Sure.
Why do galaxies have different shapes?
Well, there's essentially two different types of shapes of galaxies, a spiral galaxy and ellipticals. When galaxies collide, it destroys their spiral shape and they end up being one big blob. And that accounts for those. As far as how the spiral galaxies form, they think it's just from other things that have come in together. Everything's in motion in space. If you try to send a mission to Mars, up until about 10 years ago, the success rate was only 50% because you had to make changes in your spacecraft's trajectory because there's these different eddies in space from the gravity of the planets and other stuff that we can't account for. It might have something to do with dark matter, it might have something to do with dark energy. They don't know. So a lot of times missions missed Mars. It's not easy when you have no gravity to connect with something. Everything's in motion, everything's rotating. So in a galaxy that's forming, nothing's a direct hit. Something will be pulled in by its gravity and it'll swirl into it. And so the same way that a planet forms, the same way the galaxies form. We have 2 or 3 satellite galaxies, the large and small Magellanic Clouds that are only visible in the southern hemisphere, that are satellite galaxies to ours. They're galaxies in their own right, but they're only like 200,000 light years away, so pretty close. Compared to Andromeda, which is 2.3 million light years away. It's the closest near fully structured spiral galaxy to us, which you can see in the night sky right now with binoculars or with your unaided eye. But I hope that explains.
Sure. One more online question for the night. Have we photographed any meteors hitting the moon?
Yes. A lot of amateur telescopes have observed the moon. You see a little white flash, and we've seen them hit Jupiter and have caused great damage. In fact, Jupiter's gravity is so strong it broke up the asteroid into many different pieces, and so the train kept on hitting it as the planet rotated, and that was all caught by Hubble. But it's pretty fascinating. Yeah, so there's a lot of activity still in the solar system, but fortunately our atmosphere takes care of most of it. Hopefully NASA's missions with and these other satellites that detect the other rocks that can damage us will be discovered.
Okay, well, thanks, Jim. Thanks, Jim Head. Thank you very much. Okay, thanks so much. Thanks to everyone for coming and asking questions. Don't forget you can sign up for the Northwoods Explorers in the back, and he has some handouts that you can take with you. And also be sure to sign up for Science on Tap emails if you want to get alerts of our next presentation. Remember that our sponsors here are Oakfire, the Minocqua Public Library, the Lakeland, our Trout Lake Station, Kemp Natural Resources Station, and the Wisconsin Alumni Association, and also WXPR. Our next speaker will be Sean Rossler of the DNR talking about otters, April 6th, next month. And have a wonderful evening, and thank you all for coming. Thank you.